Good evening, ladies and gentlemen. As your project manager, I would like to say we have come so far and now we are nearly at the final stage of whole construction. But still, there were a lot of problems faced and they require a lot of solutions to be solved. Somehow we managed to solve some of the problem. But anyway, let's hear some of the summary of what we have done, how to solve the problem and the problem we have faced so far. We will start with the geotechnical problem by our Professor Hayisani. Please, welcome Mr. Bashir.
My name is Professor Butsaro from Geology part. I'm in charge in this project. We have done in 12 weeks regarding the geologic setting that we studied also in the EIS formation as well, because it's kind of the same and related with the KLCC that we gonna construct the Twin Tower. So what we have done in last 4 weeks ago, we have studied surface geology, we studied subsurface geology, and the problem is that we have the problem with the collapse with soil zone above limestone bedrock. And second is we have subsidence and sinkhole in the limestone. And third one is we have landslide. And fourth is the rockfall. And for study, and in case the rock formation, we come to conclusion is that the formation system of Twin Towers that we have to consist of 4.5 meter pure rock support on the rectangular friction eye, what we call barrette. And this design that we have designed in the EIS construction, and we are coming with different kind of formation, and we should have different kind of design of our barrette foundation. And this is what we are actually going to do in this project. It is because of we have canny hill formation that is quite hard rock, and we have to have the barrette, which means 4.5 meter thick. We penetrate the formation and we place the barrette inside it. We are approximately 104 barrette, and we make like a mid and slope upside to support the foundation of the construction. So each tower is supported by 16 cylindrical columns of high strength reinforced concrete placed on the inner corner of the star-shaped plank. And columns are approximately 2.5 meters in diameter at building base, but tapered as they rise to the floor, as well as sloping towards the center of the tower. At the center of each tower is 23 meters, 23 meters concrete core. And concrete outrigger beams tie the perimeter column to the core to provide additional stiffness to the structure. And this is our solution. Thank you very much.
Professor Bushra for your technical solution and the illustration of the problem. Now we'll proceed to the first tower nominated by Hazana Corporation. Now we have his manager here, which is Dr. YOUSRY. Now he will explain to us what is the problem faced in Tower 1 and a summary of what we have done so far. Please.
Good evening, ladies and gentlemen. I'm here to present the company constructing Tower 1. So far, the work in the last phase in the construction. The construction had a bit of withdrawal in the last few months due to some technical issues and problems with the construction, as one of the next part of the towers have been as the last part of the towers has not been exactly vertical, and now we had to correct the work and demolish some of the floors in order to rebuild it with exact vertical position, as the construction requires exact precision in order to ensure the safety of the occupation of the tower later on. So far, the health and safety during construction has reported no important issues. Following the considerations and the rules from the Malaysian government regarding the health and safety during the construction phase have been followed exactly, and that's why we avoid most of the technical problems. We hope that we will be able to complete the tower first, and ensures that the building is completed exactly as designed. And that's all.
Thank you, Dr. YOUSRY. Now we'll proceed to the second tower that dominated by Samsung Construction Corporation. We welcome Dr. Faisal Fakih to elaborate more about that.
As a construction project manager, we have to focus on the quality control, time management, cost, and so on. Our construction was to construct the Tower N. The Tower 2 of Petronas Twin Tower was constructed by the SEG consortium, which is composed of Samsung Engineering and Construction and Koko Dong Engineering and Construction from Korea, and also the local companies which Yastra and First Nationwide Engineering Center. As a general, Petronas Twin Tower started the construction work in March 1993. When we talk about the cost, we use instead of using the importing steel, we use the local reinforced concrete in order to minimize the cost for the construction. In terms of management, we ensure that the quality of the work is in very good condition by ensuring and checking the verticality of the columns, beams during the work and during the construction day and night. And also we ensure the safety of the work by providing all the safety equipment for the workers. Technically, the height of the tower is 452 meters, which consists of 88 floors above the ground, where floor to floor height is 4 meters. The construction materials being used, we use the steel and concrete, where the materials used aluminum and stainless steel. So far, there was no major problems during the construction, only minor problems which managed to be solved during the construction.
Thank you, Dr. Faisal Fakih. Now we have heard about the conclusion of the two towers. But the most important thing is in construction is also about money. Now let's hear something from our finance manager, Ms. Hajiberaheng. Please welcome.
Thank you, Mr. Chairman. Now, I would like to present you on our financial status. We have spent 1.2 billion USD for our construction, and each building or tower that we use, the cost is 400 million USD. And the rest from the pre-construction, which is include the geotechnical survey, geotechnical solution. And congratulations, guys. We could save a lot of money than the customer expected earlier, because we returned to rely on the material in local material instead of the imported material. So we could save nearly 200 million USD so far. Thank you.
Thank you to Dr. Surya, our finance manager. Now, seems like we have done very well because we could save a lot of money. Last but not least, the person who will talk with us today, she's not here, but we will do a video conference with her. She's now on the video conference with us. She is the Dr. Nisyak. She's going to talk about the HUSSIEN requirement because she is from the HUSSIEN department and she is the representative from HUSSIEN as a HUSSIEN manager. Please welcome.
Greetings to all, especially our project manager, Mr. Saharudin. Today I would like to update from my department, HSE department. As I can say today, we have a problem before, we faced it before, as the location of the construction, it have a limestone cliff. So due to the geologist's idea and all the plan that we've planned before, we propose to move the entire building, which is 60 meters away from the solid limestone into the soft formation, so that it will be safe for the construction and in the long term of construction and the long term of maintenance. So we don't have to worry about the geological part. Okay, and then regarding to the material that we use for the concrete, at first I endorsed the concrete material, but later I found out that the concrete material is risky for the tall building. But that will not be a problem. For every batch of concrete, we will be test out for the limit before it being poured to the tower. So using a wrong concrete mixture will result in disaster, but we will do the best to find the good mixture of concrete so that it will become a good one. So I think that is on the updates from the HSC part, and we are looking forward to give more updates after this, and we will try to solve the problem if we have another problems. Thank you.
Ladies and gentlemen, now we have come to an end of our meeting. And thank you very much. Seems like everyone done a very good job. We still have a little more work to do, but I hope that everyone can